derivatives. We suppose that we have a curve of y is equal f of x, and the line crosses the curve at 2 points A and B. This line creates the angle of alpha with positive x-axis. By definition, the slope of this line is tan of alpha. The corresponding coordinate for point A is x0 and y0, and similarly for point B is x and y. If we continue this line, we can make a triangle, and this angle is equal to alpha, due to a second line cross two parallel lines. So tan of alpha is change in y over change in x. Change in y is y minus y0, and change in x is this distance, x minus x0. So this fraction is equal y minus y0 over x minus x0. By inputting x, output is y or f of x. And the value of the function at point of x0 is f of x0. So f of x and f of x0 substituted from y and y0. Now we draw a tangent line at point of A, which creates the angle of beta with positive x-axis. A slope of tangent line at point A is tan of beta. In this condition, A is fixed and B is variable. If we rotate green line around point A, what would happen? We will see point B is approaching to point A. So we can say tan of beta is limit of tan of alpha when alpha approaching to beta. As a result, the slope of curve at point A is limit of this fraction. It means we substituted this fraction from tan of alpha. It is obvious that when alpha approaching to beta, x is approaching to x0. Generally, if A is a particular point at curve of f of x, a slope at this point will be limit of this fraction when x approaching to x0. Now let's solve an example. If y is equal x squared, find a slope of curve at point 2. It means we want to find a slope of a function x squared at point 2. By definition, a slope of function at point 2 is limit of f of x minus f of 2 over x minus 2 when x approaching to 2. So we can substitute x squared from f of x minus f of 2, which is 4, over x minus 2 when x approaching to 2. The limit is ambiguous and we have to eliminate the ambiguity of the limit. So limit is x minus 2 multiplied by x plus 2 over x minus 2 when x approaching to 2. X minus 2 at numerator and denominator can cancel each other. So the result is 4. In conclusion, the slope of tangent line at particular point of A is limit of this fraction when it exists. By definition, we call this a slope derivative of our function by the length of x0, and show this by f prime of x0. So in this example, f prime of 2 is 4.